the screen share? Can you guys see my screen share? So introduction. Anyone can answer with the chatting box. Can you guys hear me? Okay, so thank you, Shiba. Okay, so today's lecture note is a PDF. Not sure whether I properly share. Okay, so we are going to start week 3 of actually week 4. So week 3 of the fourth semester, the NoSQL database. Basically, as we discussed before, NoSQL database. By the way, I forgot to record. Okay, so once again, hello, thanks so much for your joining. So we are going to start week 3 of the NoSQL database in fourth semester. So today we are going to basically discuss about the Hadoop, the big data. So as we discussed before, it is true. So first of NoSQL database from it's not actually the opposite or the against or the enhance of the relational database model. Instead, we encounter problem of the size and volume of the data. So one way to address such a problem is why not we have the different file system that can handle such a big data, which is actually started from the Google file system called Hdfs. So then the Hdfs is you probably learned from the algorithm classes. So when you encounter certain problem, so one of the solution is divide and conquer. So you can divide the job or segment the job or separate the task, then solve one by one. So basically we adapt such an idea to solve the problem of the large volume of data, the big data, which means why not the chopping such a data and store the different location, which is called a distributed system. So to manage such the distributed file, so we have the distributed file system. So Google file system actually basically based on the distributed file system from Google. So Google actually started founded before 2000, 1994 or 5. I cannot remember exact year, but at the time the Google actually the way behind of the Yahoo. But anyway, both the Yahoo and the Google, what they are doing is just a simple job. So they download all the web pages in their local server, local computer. Then indexing. So we are not going to talk about the indexing in this class. So instead, we like to see how they solve the problem of when they download a bunch of files, HTML files. So how many? So every day the petabyte size level, such a file they download. The indexing is another problem. But even they cannot manage such a huge volume of the data. The data items are the document HTML file. Sometimes they may have a TXT file, sometimes image file, but basically it's a HTML file. It's a markup language file. We call it sometimes a document. So a lot of document. So for example, the UFS, GFS, or the traditional file system mostly focus on the single node, the computer. But if we put all such a data in the file system, is it easy to manage? No, definitely not, because it's too many files. It takes a long time to find the contents of the data. So Google thought about can we address such an issue? So idea comes up the distributed file system. Then we had a distributed file system before, but they think about the different approaches. So then finally they have a Google file system. But surprisingly, Google released the core part of the Google file system as well as Mapreduce. Mapreduce we will little bit discuss in this class today. So it's the programming framework to deal with such a distributed file on Google File System. They released their idea and their implementation, their algorithm. You probably heard about the fighting between the China and the US government, and actually the US government banned TikTok. Right? I never used the TikTok, but a lot of young people use such a short period video clip app, but the Chinese government decided not, they're going to sell the business only, but they are not going to sell the algorithm and source code part. So, which means the main part, algorithm, was it's kind of a recommendation system and indexing. They will not sell even when they sell the company, because that part will be the core part in terms of implementation, and later they can bounce on. Similarly, when they Google released the algorithm of Google File System and the Mapreduce, the people surprised, shocked. Then it was 2002, but that sparked the big data era. Until that time, there is no concept of big data, but people encounter the same problem. So how to deal with such a large amount of data? Yahoo had the same problem, and the other IT company had the same problem. So they adapt the idea of a Google File System. Then the Google File System donate to the Apache Foundation, the project, which is an open source project. Then the manager of such a Google File System and Mapreduce on Google, who is the local team, he actually resigned. Then started Hadoop, named as the Hadoop and Hadoop project. Then started the big data system, that is Hadoop. So if you are interested in the big data part, so you can take the big data and data analytics course. But here the NoSQL database, big data, I will put more and more the programming part on the big data and data analytics, including the Spark and so on. On the other hand, the system part like the Hadoop and Hadoop ecosystem will be discussed in the NoSQL databases. So that's the short history of the big data system. Then finally, so we are able to deal with such a huge amount of data. When we are talking about the big data, as we discussed a lot, it's a kind of relative concept of the big data. So if the computer system deal with this amount of the data, so when you have more than that, that will be the issue of the big data. But we usually call the big data system when you have over the petabyte size, the level of the data. So 100 petabytes or 1,000 petabytes, the exabyte, and so on. So when we have such a large amount of data, so we will see the little bit more details of the concept of the Hadoop big data system. There are also limitations. So like for example, later we will see, but the big data system Hadoop, they cannot actually modify the data. It's only write once. And also their data block size is so huge and there is no index. So it takes time. However, people want such the index data. People want more flexible approach. I know, you know, the big data deal with large amount of data is mostly batch job, not fast response time, the transaction. In other words, online transaction. So think about the banking system. So banking system, so if when you transfer the money to your friend, so your friend need some money to buy the lunch and the dinner, but if it takes an hour to transfer the money, nobody use. And also same problem when you are doing the stock trading. So it's 0.0001 second sometimes is the cross the winner and the loser. So, but if your system is too slow, too long, the response time, nobody use. Hadoop big data system actually is not for such an online transaction system. It's mostly batch job. which means, so I'm going to analyze the whole the data, the traffic information in United States 2019, 2020. How big is such a traffic data set? It's mostly petabyte size level. So at the time, the response time is not important. Instead, more important thing is the throughput. How fast to process the entire data. It's called a vector. It's a big data system, mostly focused on such a large amount of data. So, however, people want such the online transaction processing, fast response, the application program. But Hadoop cannot do that, and the distributed file system cannot do that. Why not? We have a database, and that is the motivation starting of the NoSQL database. Then they don't want to follow the same concept of relational database. So we know what is a relational database. I spent a little bit of time the last time, and also we will see the difference between the relational database and NoSQL database later, more details. Then we don't want to follow the exactly same, the concept and modeling of the relational database model. Instead, we'd like to be more flexible when we manage the very large data. And also, in terms of data structure, relational database deal with more like the alphanumeric data, ASCII code-based such a data. What about the image data and the video data? It's the unstructured data. When we are saying the structured mean, it's more like the modeling. Model the data. So semi-structured, it's a model, but it's not like the relational model. For example, JSON file, or the markup language file, tag-based file. So they have the certain format. It's a structure, but it's not like the relational model. So can we be more flexible when we delete such a data? So I need something software to deal with the JSON file. Then, but it's a large amount of data. So it's starting of the MongoDB or the DynamoDB. Also, if you are focusing on such a graph-based, it's a Neo4j. So we have a bunch of different types of DBMS. That is the NoSQL database. So which means understanding the big data system also very important to understand the NoSQL database. So we are going to see what is the big data, and then one of the solutions. Mostly nowadays the most popular solution of the big data, Hadoop system. Then we will see the concept, and we will have the exercise lab to practice how to use such a Hadoop system. Okay. Also, it is true. The first we can actually regard the Hbase as the first NoSQL database. Hbase means Hadoop database. So it's very, very close to the Hadoop distributed file system that we are going to see it today. Okay. Oh yes, the key. Now, this one is better. This one is better. So today we are going to see what is Hadoop, and then we will see the concept of Hadoop and the big data system, mostly focusing on the Hdfs as well as the Mapreduce. So I'm not going to introduce the Spark, which is the most important part of the nowadays. So you will learn more about the Spark, the programming, the framework on the big data in the big data course. Okay, you probably have seen this logo. This is the official logo of Hadoop. And Hadoop, when we are saying the Hadoop is the big data solution, it's kind of the group of software. It's not just one. So when we are saying the Hadoop, it's a Hadoop project. Under the Hadoop project, we have this one, Hbase, this one, Pig, this one, the Latin, the Hive, this one, and so on. School, like that we have the group of software. So probably you heard about that. The name of Hadoop actually follows the name of the toy. So dog cutting his son has a toy named Hadoop. So it's an elephant toy. So he used this name. But later, whenever we have the software, new software on the Hadoop project, they name their project name as following the animal. So pig, and the hive, and zookeeper even. So we call the group of software as the Hadoop ecosystem even. So you will see some of the example. So there's no specific reason but the dog cutting, who is kind of father of the Hadoop system, they used name of animal for the first time. Then after that, we use the name of animal for the new product of Hadoop. So Hadoop big data solution is basically the distributed system, as I said. And when we have the distributed along the network, so we may have scalability. Scalability, as I introduced last time, there are two types of scalability. One is, so you can, when you have the system, computer like this, so you need more power. So most popular way to make the strong, you can project more CPU, more the bigger memory, and you can have the higher capacity the system. So this is called the vertical scalability, but it's limited. It's limited. So mostly when we are talking about the scalable system, scalability means you can add one more server. If 2 is not enough, you can add more. So then what we want basically from the such a scale up is the more server you have, the more the performance. It's a linear performance, but not always true. Mostly it's like this. If you have the linear scalable, it's really, really good. So at the time we call that this is the horizontal scalability. So Hadoop supports such a horizontal scalable system. Then third characteristic is the fault tolerant. Fault tolerant means, I erase. So when you have such a system, what if this one is down? So failure does not always mean the hardware failure. Yes, hardware failure is not rare. It happens. It's not really frequently happen, but it happens in the system. So, for example, hard disk drive is one of the critical part for such a failure. So, HDD, as you know, it has a disk inside, and the header is moving in and out and rotate. So, but there's a teeny tiny gap between the tip of the header and the surface. So then there is a laser like that, so they can read the 0 or 1, whole or close, solid. But what if touch? Then scratch. That scratch causes several blocks damage. But even though that is 0.000001% of the entire capacity storage, but if that is the part of the header, you may not use the entire system. So that is a hardware failure. Really happen a lot. Then one of my friend who works for as a database administrator in the banking system, his job is always in the morning. So when he goes to his office, check whether there is a hardware failure on the disk. Usually one or two hard disk fail. Then what he's going to do is he's contacting the operator and replace. Because their system is not in one place, it's distributed geographically. So he called the operator and switch by the new one. Because they have already 6 or 7 times mirroring, so they may not lose. So same thing, when you have such a distributed system, if this one is failed, then your entire system is gone, and nobody wants to use your system. So even though this one is failed, your entire system is still available, then it's tolerable for such a failure. So fault tolerant is another issue. Most popular failure is this one, network. Even though there's no problem, it's still alive, but network congestion, network issue is usually happen. Even right now, some of the students maybe delayed the streaming because of a network failure. So then how can you overcome such a thing as a fault tolerant? Then open source. So that's the characteristic of the big data. So right now, the Hadoop, you cannot see exactly where the Hadoop system is, but most of the company right now, they are using Hadoop-based system, even as well as the programming framework. Okay. So you have seen such a logo. So most popular one is the Hadoop. And as I said, the pig, Latin languishing, and there is a zookeeper, and the scoop is used for the ETL, extract, transfer, and load the data. And Impala, Uzi, Solar, Mawa, and Hive, so from, but what we are interested in from such an ecosystem is the Hbase. So Hbase is almost the first NoSQL database. So which is called a column-based database. We will see more details later. And these are the part that selected the company who are using the Hadoop system. So we will see the short history of such a distributed system when we have the large amount of data. But be careful when we are saying the large amount of data or big data. Even 1969, 1970, when Dr. E.F. Code proposed the relational database model, he said it's a very large shared banking data. How big was that at the time? It's a megabyte, several megabytes. But considering the hardware capacity, considering the memory size, so whether that size of data, volume of data can be processed or not. So always we had the problem of the size, the volume of the data. But it is true. Even I learned the distributed system, especially the distributed parallel database system. Main focus when we design and the architecture of such a distributed system or large scale the system, we focus on computation. So we consider the computation rather than the other part of the computer processing, like the I/O or the transfer network. Instead, we have been interested in the higher, faster computation. That is true, right? So that's the reason what the processor you are using, that determines do you use the GPU? Because without GPU, even though you have a very nice deep learning algorithm, it takes much longer time. So that was the main reason that 20 years ago, even though we had the artificial neural network, we didn't use because of the performance. But when you have enough power, computing power, so we can do the more thing. So computation was a hard issue. So we mostly focus on the scalability in terms of computation. Whether we can get the CPU power here, CPU power here, CPU power here. Okay. So do you know the woman, the grandma in this slide? Her name is Grace Harper. So Grace Harper was the first, the female, the scientist, computer scientist, and also she was the pioneer on compiler. So she developed a compiler program first time. So then she is really popular in the computer science, especially women in computer science in the US. So she also thought about the solution of the big data. Okay, so solution definitely we need to more computer scalable, and so at the time we need a distributed system, but it should deal with single job, single task. So, but when you have n number of server, so you have the A dot out executable file, then how can you deal with the a number of power? Because number of the CPU, because this one has a thread, one thread of instruction. It's mostly focused on running on one CPU, but you have a number of CPU. Can we address this one? So at the time, for example, MPI, the message passing interface. So when I learned the distributed system and distributed programming, we use OpenMPI. So it's more there exists more strict rule when you are doing the coding. Okay, you need to allocate the job, and then this one will be processed in the number 1 node, number 2 node, something like that. So it's more difficult. Sometimes we cannot get the full benefit of scalability. We anticipate the linear scalability. When I have the 10, I want 10 times faster. When I have the 100 node, 100 times faster. But even worse, the reality is even worse. Sometimes it's not our expectation is this one. It's like this. Sometimes it's like this. More complex. Performance is even down when you have more and more the system. So it's a distributed system, the traditional distributed system, traditional distributed programming, parallel programming was really hard and complicated. So not many are used. So one of the issues when you are doing such a distributed programming is, so you can separate the job, like the A1 dot out, A2 dot out, so AN dot out. But some change of the data I may be used in another server, right? So your changed data will be stored at the first register and the L1 cache, L2 cache, finally memory. We don't expect sharing the data on the cache. But what about the memory? So to read the data from the memory is a change in data from another server. there is no way to directly read. Instead, you are going to store the data on the shared storage, like the SAN, storage area network. Then the other server read. Problem is, takes a long time to transfer the data to the hard disk drive file system and read back to the memory. It's an overhead. This one is so fast, but this part is the bottleneck. So bottleneck will happen here. Bottleneck over here. So to address that problem, people think about can we connect the memory, which is called the memory channel. That makes sense. But there are two problems. One is really expensive. This memory channel is really expensive, so when you have the 100 server, it's that you cannot get the full memory. It's really expensive. The second problem is more complex. So memory management is more complex. Logically, it should be one, but the synchronization problem will be happen. How many? All combinations. So it's programming and such a management will be very high complex, more complex. So people finally give up to use. Really. So people, it looks good. Ideas it looks good, but the reality is not so good. So they give up. When I worked as the database administrator, DBA, it was the 1998, 1999. So my company decided to purchase 32 node parallel database system. Database system. It's a relational database. It's from the Informix. Right now, Informix belongs to the IBM, but it was the one company at the time. It's XPS. Then it can be parallel 32 node database server, like the distributed system. So people really excited when we purchased this one, but reality every day is something error. Database, relational database is distributed like this. What if employee here? What about this one? Is a copy, synchronized, or the employee self-divide? So only really few table can be under this machine, distributed database system. And also, really few transactions can be implemented. So it was a really expensive machine, but we didn't fully use. Probably, I don't expect that this system survive at the time, though, because I left 2001. So, but probably it's early retired. So it was really expensive, but we cannot get the full benefit. So there is a bottleneck. Okay, the bottleneck is data. Computation. We focus on the computation, but realize that computational power is doubles up every 2 years from the Moore's law. But problem is the data changing. Even though the data is not changing, size of data is increased. So our problem is the data, not computation. That's the idea. So that is called the data bottleneck. Okay. How can we address the problem of such a data bottleneck? So we have been used to centralize the database system, centralize the file system, which is called storage area network. It's called the SAN. The reason is that we have the web server, we have the database customer, so we have the other server. So this is a server, computer node, they are sharing the data. So in your company, if your company has a customer data here, you don't have to copy, synchronize for each server. Instead, you can have one customer information centralized on. Then can be accessed by the main. Using what? Using the fiber optics channel. So fiber optic channel makes the transfer rate as high as the burst speed. So you may not realize whether this is a local server, whether this is a remote server. Because it's a fiber optic channel, fiber optics will be used to connect the system and the storage. So we can share the data. But problem is centralized. There might be limitation. It was okay the end of 20th century and beginning of 21st century. It was okay. But nowadays, this one cannot keep the whole such amount of data. So it's limited the amount of data. So terabyte level may be fine, but petabyte level data it cannot handle. So we need a new approach. So that new approach requires did I bring the cell phone? I don't know where my cell phone is. So what time is it?
It is 6:40.
6:40.
40.
40?
Yeah.
40. Okay. So we need a new system. So new system should be first. These are the requirements of the new approach to address the problem of the traditional way. So first one is the partial failure support. Partial failure support means what if this is a distributed system, this one is a fail, so network is a fail. But what we want is at least the other system should be available. Then we are going to fix such a partial failure. Then the entire system still running on. So this is the one important requirement. Then, in case of such a failure, sometimes we may lose some data, right? So, just ignore such a losing data. So, but which is not acceptable. The new system should be data recoverable, which means in case of failure, the data should be recovered. So, that is another requirement. Then, component is okay. Consistency. So consistency is very important in the database. So consistency means is whether or not we can believe the data, which means when you update data x1, but update x equal 2. So 1 and 2, you change it. This should be guaranteed, consistent. If this one is in terms of relational database, if you commit the data, it should be applied. Why this one is matter? First, you need to understand how the data is processed in the relational database. So in relational database, you have a very, very simple data object like the x. Currently, this one is 1. Then, the SQL update x is equal to 2. Then this is not the basic operation. This is the SQL statement. This is SQL statement require first you need to read the data. Read x, right? And you need to write the data. x is equal to 2, like that. So which means when you run the database query or the database SQL statement, it requires a lot of operation. So problem is because one query, one SQL statement has a number of operations. What if something happened in the middle? I update the data, but I didn't update the data Y yet. This is the statement, but consisting of a number of operations. This one will be problem, right? So in database, we define here to here, begin and end. From beginning to end, I think so you guys can see this one, begin to end. So this one is the one logical operation. So in other words, this is called a transaction. So transaction consists of a number of operations. But this is all or nothing. If the transaction is good, all operation will be applied. However, if transaction something happened in the middle, it will be go back to the beginning, all or nothing. So good means every operation successfully coming. Otherwise, if something happened, not good, so this is the rollback, revoke, go back to the beginning, all or nothing. So this is the transaction management used in the database. Actually, in terms of operating system, this is the synchronization problem. So how can the database system address the synchronization problem? Using transaction management. Then, why this one is important? So when you change the data, all one transaction will be applied by commit. Then, what is a commit? Commit means there is a permanently applied to your system. Then your system, any user who would like to access this data should get the change it, commit the data. If yes, then we are saying this is consistent. So consistency is very important. One of the reasons why relational database is so popular is because of the very strong consistency. So relational database has the very strong consistency because of this kind of the transaction management. However, commit does not mean always write the data, change the data, hard disk drive. Always the update data is in the memory. So sometimes you commit it and then x is equal to 1. We change into 2. What about here? Is it 1 or 2? If 1, if you read the data from this node n, if 1, we are saying this is not consistent system. But once this one is changed to, no matter where the server is located, when a user read the data is always 2, we are saying it's a consistent database, consistent system. What about the relational database? Relational database is really high consistency, almost perfect consistency. What about the NoSQL database? Do you think the NoSQL database is really high consistency or not? That's the question. But think about it. Which one is better? High consistency or low consistency? Or the consistent database, non-consistent database? Which one looks better?
Consistent.
Consistent. But problem? Management. To keep the consistent, a lot resource we need. It's the overhead. So, NoSQL database, give up this one. So, we will discuss the more about this later. That is a consistency. But nowadays, we have a new SQL database, as we have seen. We can keep the scalability. We can keep the partial tolerable. Even we can keep the consistency. Does it make sense? In theory, no, it doesn't make sense. But practically, we try. So we will see. So such an example later. Let me quickly check the chat box. Okay. Okay, then I introduced a lot. The main part of such a big data and NoSQL database is because of the scalability. So it should be scalable. Then what will be the solution? Then we already know the answer, the Hadoop. That's what we are discussing today. So Hadoop actually started from the Google file system. It's kind of father of the Hadoop system. And surprisingly, the Google published their idea and concept and theory in 2003 and 2004. Very well the paper. I think that I already gave you the link of that paper. I think this one, caption. Then you guys can see. No, how can I use what is the best way?
I think double click on the
Double click?
in your screen. No,
I think there is a whiteboard. This is no whiteboard. What will be the best one?
Click on in your video.
This one is better, right? Not so good. Let me. I'd like to use a whiteboard.
Yeah, I'm not sure. Okay.
Fine. This one. This is a whiteboard. Yeah. Anyway, it's okay, right?
Yeah.
So, the reason why I'd like to use the whiteboard is I'd like to okay. So, basically the Hadoop is distributed system, which means we have number of nodes connected through the network. So, our idea is a number of servers will be better than one. So to do that, so Hadoop system, as I mentioned several times, the main part of the Hadoop system is the Hadoop distributed file system. Another one is the Mapreduce. So first, Hadoop distributed file system is the file system. So So what is the file system, by the way? So what is the file system? File system is the software to deal with the permanent storage. Okay? So actually in computer system, according to the von Neumann architecture, so what we need to process the data, what we need is the CPU, processor, and memory. That's it. The problem of using memory is it's small and volatile. You lose the data without power. So we keep another one that is the permanent storage. Nowadays we are using hard disk drive or solid state disk, SSD. But this is the permanent storage. We can keep the more data, the much bigger data than the memory. Okay? Then, how can we manage such a data? Using software. What are such a software? It's a file system. So FAT 16, 32, Hdfs, ext 2, ext 3, ext 6, 8, and so on. And also UFS, Unix file system, so CFS, and also what else? NFS, network file system. We have so many different file systems, but we can use one of them or some of them as a file system. Then, what about the Hdfs? This file system mostly for local file system. Only one node, the file system. Then, we have the, for example, NTFS, UFS, Unix file system, Unix file system. Unix file system for each, they are independent of each other. They are not correlated. Sometimes you can build the NFS, network file system, but it's actually through the network, you mount this one through this. So using the network protocol, you are able to access this data. So we cannot exactly say that this is the distributed file system. But Hdfs is different. Hdfs is not this kind of the general purpose file system. Instead, it's running on top of the general file system, which means we have UFS, then the Hadoop distributed file system, and here. So when you install Hadoop, automatically recognize the number of nodes. Then each node create such a Hdfs, Hdfs, Hdfs. So when you are using the Hdfs, so for example, I have a.txt file in local file system. Only this server has a.txt. If you upload this file, you are going to copy this file to the Hdfs file system. Then a.txt, a.txt, a.txt through the network will be available along the Hdfs. Okay? So this is called the distributed file system, specifically Hadoop-based distributed file system. Then, what are the different? The first difference is block. So what is a block? What is a block? Block is, so can I use I never used this. Yeah. So first, block. So what is a block? This one. So block is, in operating system, it's the I/O unit. So block is the I/O unit, which means when you read the data, if your data is just 1 byte of data here, entire block that keep the request data will be returned. Returned to where? It's going to memory. So memory It looks like the left and right is switching. Can the student see the right like this?
It is mirroring.
I don't know. It's left and right is changed, it looks like.
You can ask them.
Can you guys see the whiteboard correctly? Let me check the. So can you guys see the whiteboard correctly? Oh yes. All right. Thank you for your response. Okay. So keep going. So block is the unit for the IO. Even though you read the 1 byte of data, entire block will be the transfer between hard disk drive to memory, memory to the CPU, something like this. So this one is used in all the operating computer system. The general size of the block, OS block, is 512 bytes. So, which means this size is a 512 byte. When you read the data, this 512 byte will be copied to the memory like this. Question: why computer system use the certain size of the block when you are doing input and output? I need only 1 byte. Then why 512 byte? Will be these all 511 bytes is not used, useless, but this block will be written. Why? Where does it go? First, this one is in the hard disk drive, file system. This one will be memory, right? Memory. Next time, this data might be higher chance to be read again. So this entire block will be used to cache. Most of the case, when you read the data from the programming, next to each other, right? You are not going to jump here and there and there and here, not like that. Mostly it's next to each other. So next byte in the same block will be higher chance to be read again. Then why not keep on the memory? So this is called the cache. So because of cache, we can use such a fixed size of the unit for I/O. What is the optimal size of the OS block? What's the optimal size? The bigger is the better, or smaller is the better? If we have the big, it takes a time to read 1 byte of data, right? You need to transfer entire block. But if you have a very small, how many? Number of I/O will be increased. More context switch if you are taking the operating system class. So whenever you read the data, CPU stop, interrupt. Then the context switch will be happen. Then read another block, context switch, another block, like that. So it's the overhead. So usually 512 byte size is used in operating system. In big data, this block size is changed to the 64 megabyte or 128 megabyte. Really huge block. In other words, extreme case. I'm going to read 1 byte of data from Hadoop. You see here. But entire 64 megabyte block will be loaded into the memory. Really huge size. Even 128 megabyte. Because of that, when you build a big data system, memory size is critical. you'd better have the processor or design your computer node with a bigger size of the memory. So memory is critical when you build a Hadoop system. Why? Why we need such a big size of the memory? Because our goal is not fast response time. Instead, we want to process a large amount of data. So at the time, if I/O, number of I/O increased, what happened? It's an overhead. It's a more context switch, more CPU context switch. It's an overhead. So performance will be down. So we want to reduce opposite, less I/O. To make the I/O less, we need to increase the size of the block. Right? That makes sense. Problem. I need only 1 byte of data, just 1 byte. Takes a long time. So this approach that's not good for what? Fast response time. So online transaction processing, this one may not work. But Hadoop system is not for such a online transaction processing. Instead, more like the batch job. So batch job, so this one is working. So this is one important characteristic, the block. Second, when we upload, so as I said, Hadoop distributed file system is reside on the existing file system. Then we copy a.txt to the Hadoop. What if this data is gone? This system has the problem. You may lose a.txt, right? Because of that, Hadoop manage at least the 3 copies of each block. Which means, if you upload a.txt here, 1 copy, 2 copy, 3 copy, a.txt. 3 blocks, 3 copies of the block will be created. So, if your file is 1 petabyte size, actually when you upload the data, it will be at least 3 times, 3 petabyte size. Oh, it's a waste of space, right? But think about the price of a disk drive, hard disk drive. How much expensive nowadays? 2 terabyte size is $40, $50, right? If you purchase the 2 terabyte, 1 terabyte, it's less than the $50, much cheaper. Disk drive, the hard disk drive, the price is the drop, so we don't care. Instead, what we want to do is, if one of them failed, the other 2 are still survive. If 2 of them is failed, the one is survive or line, so we can continue to use. So this is the another characteristic, the 3 copy. So first, the block, is the bigger size of the block, and also 3 copies of the block. This is the main characteristic of the Hadoop distributed file system. Then, another characteristic is, once it writes the data, you cannot update. Only write once. Then reading is fun, right? Read many. Write once and read only. It's a read only. Okay? Why? If you allow the modify the data How can you modify the data? You need to read the data here and copy. Before image, after image. And change it until coming. So it's overhead if you allow the change the data. So this system does not allow to change the data, update the data, delete the data. Or you can delete the data, entire data. So only read only to avoid any overhead. So this is the another characteristic of the Hdfs. Then Mapreduce. There are more. So I will say that there are more characteristics later. Then let's say that this is the distributed file system. Just like the many other distributed systems, Hadoop basically based on the master So this is the master for example. One master and many slaves. So master plus slave, the architecture. Then at this time, this master is called naming node. Naming node. So when I am saying the node means one computer, one server. So naming node, master is called the naming node, and slave is called the data node. So if I write down the for example, DN means data node. Data node 0, 1, 2, 3, 4, data node N. Master node only one master node, but because of this is called a single point of failure, which means if you have something happen on your master node, your entire system is gone. If you're the one of slave node, data node is gone, still survive, still alive. It's a partial tolerance. However, master node is not. Because of that, we have standby naming node. Standby naming node. Standby naming node is based on the HA, high availability. If one node is down, the another node is standby and take over the job. So we can avoid the downtime. There is a secondary naming node. So secondary naming node is not the standby node, it's the additional helper. So if a naming node, the master is so busy that it cannot do anything, that may happen. So if instructor is so busy, so I cannot help any student. What if I have assistant? Then he can help the other student. That is the secondary naming node. So these are the overview of Hadoop system. Then once we have such the Hadoop system, why did you build such the Hadoop system? Processing. So we'd like to process the data. How can you process? At the time, you can use a Mapreduce. This is called the programming framework. This is not a language. This is not a specific language. Instead, it's kind of a programming framework. So this programming framework nowadays used a lot. Spark also used the Mapreduce concept. And Mapreduce is nothing, it's not the brand new idea. It's a kind of also divide and conquer approach. So the meaning is that the traditional approach in the traditional concept of the distributed system is we try to utilize the CPU power, CPU power, CPU power. That caused the problem as we have seen. Instead, why don't we move the processing to the data. It's the data driven. Instead of bring the data into CPU memory, CPU and memory, that's what we did. So read the data from centralized server and node process and the result like this. So we brought data into the computation. That caused the problem. So why don't we change it? Which means such a processing move to the local data because our data is here. So our Mapreduce code. So you are going to code the big data processing. That code will be processed based on the block. It will be processed on the node. So it's called the locality. So locality is the most important characteristic of the Mapreduce. However, we process here. This is called the mapping. So we map the process into the data block. But eventually we need to collect all the results, right? So this is done, this is done, this is a separate. We need to combine all of this into where? That is called the reducer. So basically, our big data processing is a two-part. Mapper, map. Then, using locality, data locality, we process in a local data block. The result will be combined into the reducer. Finally, it will be done. Job is done. So this is called the Mapreduce. Mostly Mapreduce and Hadoop developed with Java base. So Java is the major programming language. What if I do not know Java? So there are more the programming language supported using Hadoop and Mapreduce the streaming, the programming. So Python is doable and shell programming is doable. Then this one is enhanced to the Spark. So Spark is also distributed data framework. Mostly it's based on Scala and Python. But Spark does not depend on the source of data. Mapreduce is only based on Hadoop. But Spark is based on the Hadoop, but also other local file, streaming file, and many other sources. So this is called the Spark. So this is the overview and the characteristic of the Hadoop system and so on. So Hadoop use the large size of the block, okay, and that is one of the most important part of the Hadoop. And I think I already explained most of the things that we'll quickly check. Okay, so because of that characteristic, if one of them is failed, still two other copies are available. Also, sometimes one node is very, very busy, right? Then, if the master node with the fear that this node is slow, then ask another node, process the exactly same job, and see the result, which one is faster. If this one is faster, then forget about this one and take this node result. This is called the speculation. So speculation is used in the Hadoop system also. So we can guarantee the best performance. Erase. So our idea of the very high level overview of the Hadoop system is we are going to divide the data into blocks, but block size is really huge. Then we can have like this, so slave node, data node. So each data will be processed as a mapper, then combined into the eventually reducer. This is the overview of the big data processing using currently. Then benefit is really linear scalable because each node they are independently the processing the local block, right? So the more the node you have, then the process it, then eventually combine. So we can get such a the linear scalability. Also, you can real time scale up and down. So if the admin realize, oh, this job is really busy, then add more server. If we are using the cloud computing, for example, AWS is called the elastic server. For the Hadoop system, they name elastic. Elastic means you can stretch up, you can shrink down. So dynamically change the scalability. Google also support such a thing. You can set the minimum number of nodes. Depending on the your job is huge, then automatically scale. Then if not being used a lot, then reduce. The fault tolerance, so you have seen the example of the fault tolerance because it has at least 3 copies of that, then you can keep it. So which system used such a the Hadoop system? Actually nowadays more like the data warehousing job as a backend and also data processing analytics. Like this one, text mining and index building. Actually Google uses a lot for such a Google file system for index building. Even pattern recognition, collaborative filtering in recommendation system, and so on. This is a big data problem. And there are some examples of using the Hadoop. So I'm going to skip this. So benefit. So cost-wise. So somebody the benchmark the Hadoop system. Usually one server, one node price is 3,000 to 4,000 US dollar. If you have 100 nodes, so 4K, it's just 400,000, even less than $500,000. It's not expensive, right? It's not expensive system compared to the price of the traditional, the distributed system. Last time, so we drastically reduced the time, so we can get the performance. Flexibility, linear scalability, and then, what time is it?
7:20.
Okay, let me stop here, then we will have the 10-minute break, then we will continue for the Hadoop basic concept. Okay, so Hadoop. So I think we I already explained the details of the Hadoop, so we can quickly go over the concept of the Hadoop system. Okay? So when we are talking about the Hadoop, so there are three main components. One is the Hadoop distributed file system. The second is the Mapreduce. The Hadoop distributed file system, Hdfs, is the storage for big data. Then the big data can be processed by the Mapreduce framework, programming framework. So this one will be used for this one is for the file system, the data storage. It's a data storage. And then this one is for the Mapreduce is the programming. Then there's another one is called the YARN. So YARN is called the resource manager. So, but I do not introduce the YARN here to focus on because our main goal concept of the discourse is to understand how data is processed and eventually NoSQL database. But YARN is important. It's from the Hadoop version 2. So yet another resource negotiator, which means so we have bunch of node cluster. Sometimes one node is very busy, the other one is slow. And also there are the nodes, they are not being used idle. Then we want to use such an idle server. So if the manager, the naming node, know which server is busy, which server is not, then we can ask the job to the node which is not busy. Okay? So who decided? The YARN is a resource manager. So first version of Hadoop actually do not have this. So sometimes, even though several nodes are not busy, it's idle, but it cannot be used. Okay? So they put another one, so it's a resource manager. So when we talk about the Hadoop system, three main parts. One is the Hdfs file system, and second is the Mapreduce programming. Third one is the YARN, the resource manager. But we are talking about the first two, the storage as well as the programming. Okay? Then plus, we have such a additional software package. So these are the software. Each of them has a specific purpose. So for example, Pig is for the programming language. Hive is also programming language. It's a SQL style, the programming language. It's a very similar, it's almost the same as the SQL style. Hbase is since the Hdfs is write once, the reading only. And also there is no update. So it's very hard to manage such a data. There is no index. So to address that, Hbase is the first NoSQL database based on Hadoop. The storage, as a storage, Hbase uses Hdfs. But on top of that, there exists the memory-based, the Hbase. So that manages the change in data and so on index. So this is the Hbase, not memory-based, is on top of the system. Flum is data transfer, Scoop is also data transfer. So we have the many software. So this is called the Hadoop Ecosystem. So then, when we are talking about the Hadoop system, it combines all of this. So this is the illustration of the Hadoop system, and then Mapreduce and Hdfs. So there are several important characteristics of the Hdfs as we discussed before. It used the larger size of the memory, okay, not memory block. So larger size of the block and at least 3 copies of the data. Okay. Then the programming, I will introduce a little bit more about the this Mapreduce program. Let me. Yes. So, still real. This is the naming node, master node. Data node 1, data node 2, and data node, let's say n. So we have n number of data node and with the one master node. So when you upload the a.txt file, let's say this is a 150 megabyte. We are going to use the 64 megabyte block size, like this. So if you upload this one, so how many blocks do we need? 3 blocks, 64, 64. The last one is we don't have to use the entire 64. This one is 128, only 22 megabyte. So block 1, block 2, block 3. We have 3 blocks. So naming node, no. So first, a.txt has block 1, block 2, block 3. Also, block 1, how many copies? 3 copies. So block 1 is here, and block 1 is here, and block 1 is here. So DN node 1, node 2, node 3. Block 2 is, for example, here, here, here. So data node 3, 4, and block 3 is the same thing. Block 3 and block 3, block 3. So we are going to use DN1, DN3, DNN. So naming node nodes has the metadata of each of them. So also, this is additional thing. Naming node always check whether each data node is alive. It's kind of the ping. So it's called a heartbeat. Every 60 seconds, check the status of each node. Are you alive? If yes, it's okay. But sometimes the response is very slow. So you can keep recording of the status. Data node 2 is not available. So data node 2 will not be used. Like this. Then, at this time, DN1, DN3 will be used based on the metadata, like this. This is a heartbeat check. So, also, all the Hadoop system, their communication is based on the HTTP protocol. It's based on TCP/IP. So, even you can see the data using web browser. If you are using the URL, so you can actually see the data using the web browser because all the communication are based on the HTTP. Okay. Then finally, I'd like to introduce the Mapreduce program. So Mapreduce program is this is our current Hadoop system. With the data a.txt. I'd like to read the data a.txt, then process something. So that is a word count, for example. So word count is kind of the hello world style, the big data program. So what this program is going to do is the word count is simple. But first read the data from the file a.txt file. Then how many times appear in the text for each word? A, 10 times. B, 20 times. So box, 2 times. And the cat, 10 times. and zebra 1 time, like this. In order of the alphabet word, how many times? It's a word count, simple. You can implement this one with your own code without considering this. How? Read the first word. Then say A1. Second word, check whether there exists. If not, and add in order by sorting. However, it takes a really long time if the file size is bigger. So what we're gonna do is first upload this data into the Hdfs. It's loaded, right? Then first I'm going to explain the concept of mapper and reducer. Mapper is actually mostly it's emission. So emit, the word is Hadoop understand each any document, any data line by line. So one line will be one record. One record is one data item. Always line by line. How does the computer recognize the line? There is a special character /n, new line character. So new line character will be used. Okay. So whenever you see the new line, it's an invisible character. It's called the white character. So this new line character will be used record by record. So first read the data. But this time the one more important concept you probably learn in your if you took the big data course, it's a key value. Key value concept. You need to understand the key value concept. We will see also later some of the NoSQL database follow this concept, key value. What is a key value? Key value means we are going to understand the data as a key and value always. If you already took the database course, oh, I know what is a key. Key is a primary key. Primary key is a unit and number. So we can use the key primary key as a search. When you search the data, you can use the key value. Primary key. No. In this, the concept key value, key is not primary key. Key means just a key. Value is the data. So key can be anything. Like the key is the number, key is the offset number, key can be the data, whatever. So key is just key. It can be used to read the data value. So for example, first job of the Mapreduce program is you need to check by line. One line is the first line is the value. Okay? What is the key? Number one. One can be the key. Number two. Two is the key of the second line. Or what we're gonna do here is we'd like to use the offset. Offset means how many bytes from the beginning. So this one is definitely 0. This one is if this one is a 20 byte, this one is a 21. Like this. Anything can be key. It doesn't have to be unique. Key is useful later compare. Only reason of the key is compare. Later we will see. So, for example, first line is I am a professor. If you have such a line, this is a value. Then next thing is that this is a word count. We are going to split by word, right? Also, output should be key value. Key is I, value is 1. Like this. This one M, 1. A, 1. Professor, 1. Next line is the same thing. We have a bunch of key and value. So this is called the mapper. So mapper is doing emission. Emit the data to make the key and value for your task. Task is a word count. Eventually, same key will be combined by what? The number. Then that will be word count. So this is a mapper. So mapper will be here. Block 1. We are not going to use this. Only one block will be selected. However, this one, and block 2 is here. And then block 3. So 3 nodes will be selected for the what? Is it from here or here? Outside, right?
Yeah, I think so.
Okay, so this one will be used for mapper processing. This one will be used for the mapper processing. This one will be used for the mapper processing. Then output of this one. So this is not final output. Let's say that if there's another I. Here probably I. So all I instead of I1, we can say I1. Okay? What about the I3? Which one will be better? 111 or I3? This one looks better, but this one requires plus. It needs computation. So we want to avoid any computation here. So we are not going to add up here. Just the I111 will be final output of the mapper. This one has such a thing, this one. Then send to where? This one will be selected the reducer. Naming node, master node select the reducer. Then send the data. Then reducer will combine all of the value for same key. Then final output is I 10 times, A 10 times, B 20 times, box 2. And so on. So this is the word count example for Mapreduce programming. For example, if during the mapper, if this one looks slow, then naming node asks another block 2. Please run the program, the same thing, because this one is slow, and see the performance. If this one is faster, take this one and stop this. Like this. This is a speculation. And so this is the how does the Mapreduce work on the Hadoop system. At this time, this is called, instead of I1, so we make the I111 the list for the value. This is called the shuffle and sort. So it will be sorted to reduce the overhead of a reducer. Okay, so I already explained this. So block 1 will be copied. The one block has the 3 copies like this, and so on. Who manages that? The naming node that manages all the metadata information. Then finally, there are a bunch of different ways to access them, such as Hdfs. You can use the client mode, but in your exercise lab, you are going to use the Hadoop shell. So Hadoop shell will be used to access the Hadoop system. So this slide clearly shows how data is located on the Hadoop cluster and how can you access the data through the naming node over here. There's a standby node because naming node is important. It's a single point of value. But there's a name of secondary node. Secondary node does not mean the standby node. It's a helper. assistant of the naming mode. So in your exercise lab, you are going to practice with the Hadoop shell. This is called the Hadoop shell. So on your, this is called the prompt. So in your prompt, so this is operating system prompt. When you install the Hadoop, you don't have to install on your virtual machine. Virtual machine has been set up already, configured everything. So you can just start to use the Hadoop shell with the FS. Nowadays it's called the DFS, distributed file system, Hdfs, DFS, but the same command. So we are going to use the Hadoop shell, Hadoop command like this. But it's very generic. Generic means it follows the general command of the shell. If you know the bash shell, it's pretty much similar. You can see the ls. So list the file on Hdfs. ls/root. Okay, and put means from local file system to Hdfs. It's a put. Get opposite the Hdfs to the local file system. So on. Cat see the content of file. So you will practice all of this after this class. So then there are two main components of the Mapreduce. So one is a mapper. So mapper mostly actually emit, decompose the input data, then make the key value format. Then reducer will collect all the reducer output, and final algorithm will be applied. So this is a reducer. In between, before output of a mapper sent to the reducer, there is a shuffle and sort. As I explained here, shuffle and sort reduce the job of the reducer. Okay. So this is an example of the word count example for Mapreduce programming. This is the input file, the cat set on the map. So you probably see that this example during the big data programming, big data analytics with the Mapreduce programming. The final output, what we want is the word, for each word, the number of the occurrence, like this. How can we do that? So mapper assign the job to each local block. Then each local block perform the mapper job. Output of the mapper will be sent to the reducer. Before that, the shuffle and sort make the intermediate data. So on. Okay. So this is another example of the Mapreduce programming. Let's move to this one. So here, input data is like this. It is true. I think as far as I know, the first program, the project of the Mapreduce programming is from the network data analysis. For example, this one is the log information, network log. So you probably know about the DDoS attack. DDoS, the attack is the sender sends the request to the specific port, the huge request. Then that port will be disabled. That is a DDoS attack. So network admin would like to know which one is the attack, which one is the normal. So at that time they can see such a log file. The log file has the sender IP address, then the request, what information they asked. So this time, this data analyzed such a log data from the how many the requests for each type of file. So for example, our expected output is like here. So HTML file is 888, and GIF, this one, and so on, like this. To do that, first read the data from the log data line by line and cut by space. We don't want this we don't want, but we want this part. So first this part will be emit, the segment, then chop, and eventually GIF will be key, and this one will be value. The question is, how can we get such a data from the line? Because of that, regular expression is very, very useful when you are doing the data analytics. So regular expression is the line, the processing for the text data. So like the split by the space, or the switch and the swap, change and remove. So such the regular expression will be used to process such a data. Okay. So such a Mapreduce program is fully utilize the characteristic of the Hadoop system. So automatic the parallelization and distribution. Meaning is that one of the main issue of using the distributed programming or the parallel programming is too difficult. You need to consider how many server and which one you are going to use for the speed. Instead, the Mapreduce programming framework set aside all housekeeping job. I don't have to know about where is the data and how many data nodes and how many copies. I don't care. What I want is I'd like to focus on my algorithm, my task. For example, word count, I'd like to count each word, then sum up by the word. That's mine. I don't care how many nodes. So the faster the better. And who is taking care of that? Such a housekeeping job. Hadoop is taking care of the whole housekeeping job. Then user, the developer, only focus on the task, their algorithm. That is a benefit of using Mapreduce program. Okay, let me start here. So I'm not going to explain the details of the example. So you guys can quickly go over what are the example of the project using the Hadoop, like the ETL is definitely, and the data warehousing, and then so on. And some company example, you can see it is true nowadays. Most of company they are using both relational database as well as the Hadoop, the system. So mostly Hadoop system is used for the back end processing, data warehousing or data analyzing. On the other hand, the relational database will be used for online transaction processing, quick response, the transaction. Okay, so that is the concept of Hadoop. So then, we understand what is the Hadoop, but still, it's not good enough in terms of data management, because it's only write once, and the index is not supported. Can we address that? That is the starting point of the NoSQL database. Okay, I'm going to start here today's lecture, but today is the exercise lab, first exercise lab day. So instead of having the live exercise lab, the GA, the MC already uploaded the exercise lab on the class the playlist. So let me show you the example Stop share. I'm going to show the example where is the recorded video for exercise lab. Here. So this is a link. So you can see the exercise lab. Let me share the screen. So if you go to the link to the our playlist, so the last one is the exercise lab. Please watch the video, then follow the instruction. Before that, before watching the video, you need to download the virtual machine, which is linked at the first page of Canvas. So please go to the Canvas and download the virtual machine. You need two software, either the VirtualBox or the VMware. You can use either of them. Then using that software, so you can start the Hadoop is already configured. You don't have to do anything. Just download the VM and start the VM with the VM player or the VirtualBox. Then you can follow the instruction of the VMC and complete your exercise lab 1 first. Then to verify whether you guys did or not, please submit the screenshot of the exercise lab. So mostly last stage, you can copy and paste, not copy and paste, get the screenshot of the exercise lab and submit to the Canvas. Okay. Okay, so that is the. Let me stop here. So that is all the things. So after the lecture, you have the 20 more minutes. So during that time, why don't you try to complete the exercise? Okay, any questions? Any questions? If you want, you can unmute, then ask the question. Okay, if there's no other questions, we are going to stop here. So thanks so much for your attending and start your first exercise lab to practice the Hadoop. So this exercise lab 1 is for the Hadoop. Okay. Thanks so much for your attending and stay safe, and we will see the next week. Don't forget to complete the project phase 1. So task 1, phase 1, selecting the NoSQL database and submit the short brief, the explanation of the database. NoSQL database. Okay, thanks so much. We will see you next week.